As organizations build AI agents, a challenge that they face is with getting these agents to work together. Every agent to agent integration becomes a custom project. One agent exposes REST APIs, another one uses gRPC, and a third one may have its own conventions. Discovering agents is also a design time manual process, which makes it harder to scale. When agents communicate with each other, they may interpret requests differently as they don't share any assumptions, history, or context that is related to the task that they are trying to solve together. And the result is exactly what you see here: fragile integrations, high implementation effort, slow collaboration, and limited visibility. Humans often end up acting as a glue between these agents. And this is a problem that A2A protocol is designed to solve. Without a common standard for agent to agent communication, the number of integrations grow faster than the number of agents. A2A introduces a common protocol that any compliant agent can use. It standardizes how agents exchange messages, coordinate work through tasks, discover each other's capabilities, and collaborate in a secure and reliable manner. Instead of building integrations every time a new agent appears, organizations can integrate faster, scale more easily, and evolve their ecosystem over time. There are five concepts that are worth remembering because they appear throughout the protocol. Agents here are the participants. Tasks represent units of work that agents perform with clear goals and life cycles. Messages are conversations that move these tasks forward. You can group multiple messages under a task. Artifacts are outputs that are produced along the way, such as a text file, an image file, or a code file, etc. And agent cards allow agents to discover capabilities of other agents dynamically at runtime. If you understand these five concepts, most of the A2A protocol becomes very intuitive. Let us begin our understanding of A2A by understanding each of these concepts more deeply, starting with agent cards. Before an agent can delegate work to another specialist agent, it needs to understand a few things. What are the agents that are available that can help with this task? What are their skills? And how can I interact with these agents? Agent cards solve these problems. Think of them as combination of API specification and a capability catalog that is designed specifically for agents. Agent card can describe where to connect with an agent, how to authenticate with it, what skills are available, and what formats are supported. With this information, agents can dynamically choose their collaborators instead of relying on hard coded integrations. This is an example agent card. A2A agent cards are written in JSON format. However, don't worry about memorizing the JSON, but try to understand the type of information the agent card provides. First, it tells another agent where to connect through an endpoint. Second, it explains how to authenticate, including the security scheme and any required scope. Third, it advertises agents' skills. For example, here, agent skills are web search, document retrieval, and summarization. Fourth, it describes the kind of information agent understands and produces through supported content types and output formats. Beyond that, there may be additional capabilities such as support for streaming responses or push notifications, etc. And finally, it shares the provider information, which helps identify who owns and operates the agent. Agent cards are contracts that enable dynamic collaboration at runtime to decide whether the other agent is the right collaborator. Let us look at an example flow of agent discovery. Agent B, which is a restaurant agent, publishes its agent card with skills that it can find nearby restaurants. It also provides a task endpoint for other agents to submit the work. Agent A is a planner agent that has a current task from the user to find restaurants in San Francisco. It searches for an agent in the agent registry and gets the agent card for restaurant agent. By inspecting the metadata at runtime, it decides to invoke agent B, which it does by sending the message at the endpoint that is advertised in agent B's agent card. So, this is how dynamic discovery happens at runtime. The key benefits of agent cards are that they support runtime discovery instead of hard coded connections. They enable routing by skill, where rather than invoking a specific agent by name, a planner agent can select the best agent for the task based on the skills that are advertised in the agent card. Agent cards support evolution of agents without rewiring them. As new agents become available, you can simply publish their agent cards, and existing planners don't need to be redesigned or reconfigured. For example, a new procurement agent can join the ecosystem without breaking the current workflows. And the fourth benefit is that agent cards make it possible to tap into expertise wherever it exists. It could exist across internal teams, partners, or third party vendors. This allows dynamic capability based routing to specialist agents across teams. Now that we have understood agent cards, let us look at how agents interact with each other. The second component of A2A is the messages that two agents exchange with each other to work together. At transport layer, A2A uses JSON-RPC 2.0 to exchange structured requests and responses. You can think of this as envelope that carries communication between agents. But unlike traditional API calls, these messages are task centric. Agents are not just asking a question and getting an answer, they are collaborating on work which requires multiple messages. Each message can represent requests, clarifications, progress updates, results, or even issues that arise during execution of that task. Because many tasks can take long time, A2A also supports streaming updates using server sent events or SSE. Instead of polling the status, agents can receive real time notification such as I'm working on this, I need additional input, the artifact is ready, etc. And underlying all of this is the shared idea of tasks and artifacts. Tasks capture the state and metadata of the work that is being performed, while the artifacts represent the outputs that are produced along the way, such as reports, documents, images, etc. And this is an example of how A2A messages look in practice. Under the covers, messages are simply JSON RPC with a structure that agents agree upon. On the left, you see Agent A is submitting a task to Agent B. The message has a message ID so that it can be tracked, a method that indicates the action that has to be performed, and the parameters that contain the information in actual request. On the top right, you see an example of how agent B acknowledges the request and returns the task state, which in this case is task has been accepted. And it also has a task ID so that it can be tied to the current task. And because work may be long running, agent B can stream updates back using server side events. On the lower right corner, you see an example of an event where agent B is indicating that it is still working on the problem and it is 35% complete. A2A supports different interaction modes. The three interaction modes that you see here use the same task model, the same task life cycle, and the same message semantics that we just saw. The only thing that is different is the delivery pattern that is chosen based on the nature of the work. The first interaction mode is request response with polling. This is the simplest approach. Agent A submits tasks to Agent B and periodically checks back for status updates until the result is ready. This works well for short running tasks where completion happens quickly and the overhead of polling is acceptable. The second mode is streaming with server sent events. In this mode, the agent maintains a long lived connection for real time conversation with the other agent. Agent A submits a task, and as we saw in the previous screen, Agent B streams back updates in real time. I'm working, it is 25% done, the artifact is ready, etc. This creates a much more interactive experience, and it is ideal when users benefit from seeing incremental progress or partial results. The third interaction mode is asynchronous push notifications or webhooks. Here, agent A submits a task and then moves on. It does not maintain any long lived connection. When the work is finished or when an important event occurs, agent B sends a notification back. Think of this as saying, "Call me when you're done." And this pattern is great for long running workflows such as approvals, overnight processing, or integrations with external systems. The key takeaway here is that A2A does not force a single communication style. Whether you poll, stream, or use callbacks, agents still speak the same language. There are different delivery mechanisms, but the same task model and consistent lifecycle semantics. Let us bring everything together and walk through a complete A2A interaction to understand the message flow. In this example, Agent A needs help with analyzing Q1 sales data, so it delegates work to Agent B. The interaction begins with a request message, and at this point, Agent A simply describes the work that it wants done. Notice that there is no context ID or task ID yet. Agent B evaluates the request, accepts the work, and returns an initial message. This is important because Agent B now creates two identifiers. First is context ID, which represents the broader conversation between the agents, and second is the task ID, which represents the specific unit of work, which is to analyze Q1 sales data. Agent B completes its work and returns the sales insights artifact to Agent A. Since Agent A has identifiers for context and task, the follow up interactions become much simpler. Agent A continues the conversation using same context ID and task ID, and it asks Agent B to summarize the findings into three key takeaways. Agent B acknowledges the work with the task status working and finally responds back with another artifact, in this case, the text summary. So, the key takeaway here is that agents throughout have a shared understanding of context, task, and task status, which allows stateful collaboration. Context keeps the conversation coherent, tasks keep the work organized, and artifacts capture the outputs that are produced along the way. When agents communicate with each other, another important concern is how can they trust each other? A2A does not define any new authentication protocol. Instead, it relies on proven enterprise mechanisms such as OAuth, JWT, API keys, or MTLS. The flow typically starts with Agent A discovering Agent B and retrieving its agent card. The agent card advertises the authentication requirements, whether it's OAuth, JWT based access tokens, API keys, MTLS, etc. Agent A then obtains or presents the required credentials and makes its request over HTTPS. Agent B validates these credentials according to its own security policies before deciding whether to accept the work or not. So, here the key idea is that A2A standardizes collaboration, not identity. You still rely upon the proven security mechanisms that are already implemented within the organization. We just discussed an example of how two agents can authenticate with each other to collaborate. However, real enterprise workflows rarely involve just two agents. Let us look at a multi hop agent workflow when it comes to authentication. Let us say Alice asks a planner agent to book her Seattle trip. The planner agent can coordinate the work, but it doesn't have the capabilities to do the work, so it decides to collaborate with the travel agent for this request. The planner agent requests a delegated token from authorization server on behalf of Alice. Notice that this token is very specific. It is intended only for the travel agent and it contains the permissions that are needed to book the flights. The planner agent then invokes the travel agent using the delegated token. The travel agent validates that the token is actually meant for it and the requested action falls within the allowed scopes. Now suppose travel agent needs budget approval from finance team. Instead of reusing the original token, it performs a token exchange with the authorization server. The server issues a new delegated token with different audience and narrower permissions. This time, it is only allowing budget validation by the finance agent. The finance agent validates the token and confirms that the work that it has to do falls under the allowed scope. It performs the work, and the travel agent confirms the trip, and the planner creates the final itinerary for Alice. So, this is the end to end flow of how authentication works in a multi hop workflow. At this time, you might be wondering if A2A solves all the problems with agent to agent collaboration. The answer is no, but it does solve some of the most important ones. The biggest one is standardization. A2A gives agents a common way to discover each other, exchange messages, and coordinate work through shared task lifecycle. That's why you see a strong yes for lack of standardization problem. For challenges such as semantic alignment, context sharing, reliability, and trust, A2A helps, but only partially. It provides the structure and hooks. For example, agents can exchange context and task state, but A2A does not guarantee that two agents will interpret the information same way. Similarly, it supports secure collaboration, but it doesn't define the security mechanisms themselves. And then there are capabilities that are completely outside of A2A. Things like enterprise scale monitoring, long term memory, policy enforcement, evaluation, and operational controls still require additional infrastructure around A2A. A common question that is asked very often is that what is difference between MCP and A2A, as both these protocols help the agents to outsource work. Also, which one should be used for a particular use case? The answer is that these protocols operate at very different layers and either of these could be used. MCP is about giving an agent access to capabilities and tools in other systems, whereas A2A is about enabling two agents to collaborate with each other. With MCP, you're delegating execution, whereas with A2A, you're delegating the judgment. MCP interactions tend to be deterministic and repeatable. Given the same input, you generally expect the same outputs. With A2A, the agent is trusting another agent's reasoning, expertise, and decisions, which is an altogether different design choice. In A2A, agent is saying, here's the outcome I'm trying to achieve, figure out how to do it. Agent to agent interactions are more probabilistic. Two specialist agents may take different paths and still arrive at acceptable answers. And this difference changes how we test and troubleshoot these systems. With MCP, we are debugging tool calls such as inputs, outputs, API logs, whereas with A2A, we debug reasoning. Observability becomes much more important with A2A, and human approvals and guardrails become part of the workflow, especially for high impact decisions. And enterprises do not like the idea of blindly trusting agents to exercise judgment. They introduce guardrails to maintain control. The first guardrail is to keep deterministic systems underneath. The agent should reason and decide what should happen next, but the tools which are deterministic execute the actual actions. Second, they narrow responsibility. Instead of building one super giant agent that does everything, organizations create specialist agents such as invoice agent, compliance agent, travel agent, etc. By maintaining a smaller scope, organizations avoid variability and achieve a more predictable behavior. Third, they introduce the reviewer agents. One agent produces an answer, another agent critiques it before it reaches the user or triggers an action. Think of it as a peer review for AI systems. Fourth, they trace everything for end to end visibility about who made the decision, what prompts were used, which tools were called, and how the task evolved. Without observability, these systems with multiple agents can quickly become impossible to operate. Fifth, for high risk scenarios, humans stay in loop. Actions that involve money, legal commitments, or irreversible changes often require explicit approval before execution. And sixth guardrail is to require structured outputs. Instead of returning free-form text, agents can return recommendations, confidence scores, assumptions, and citations in the structure so that evaluation becomes easier and downstream automation is safer. And this image is a reminder that A2A is only a piece of the puzzle. A2A tells agents how to collaborate, but it doesn't magically solve everything that is required to run these systems in production. At the center, you will notice the A2A gateway. In many organizations, agent to agent traffic doesn't flow directly between hundreds of agents. Instead, a gateway becomes a control point for routing requests, enforcing policies, and providing a consistent protocol layer. To the left are the capabilities that make agents discoverable and observable. The registry allows teams to publish and discover agent cards. Observability gives us end to end visibility through logs, metrics, traces, and audit trails. Without proper observability, debugging the multi agent systems can quickly become very difficult. On the right are the capabilities that make these systems trustworthy. Identity and access management and security handle authentication, authorization, scopes, and token exchange. Governance introduces guardrails, approvals, compliance controls, and human oversight where appropriate. So, the key takeaway is that A2A defines how agents collaborate. The surrounding platform capabilities make that collaboration secure, discoverable, and observable. And let us bring everything together by looking at a practical implementation of A2A. In this architecture, the human expresses intent. The planner agent orchestrates the work and collaborates with specialist agents using A2A. These specialists use MCP to interact with deterministic enterprise systems such as SAP, Salesforce, and APIs. Human approval is introduced wherever oversight matters. This architecture combines the strength of both approaches. A2A coordinates expertise, whereas MCP executes actions, and humans remain in the control where it matters the most.